basically just going to be.
How'd you know?
Athletics.
You graph it?
I learned it.
Or you learn it?
No, look, I don't know how you.
Yeah, you're gonna need a Taylor series to find it, but it's actually interesting.
Because look, f of x is sine, so f prime x equals g of x.
Okay.
The g prime of x.
So let me show you how it actually works. So Austin, have a seat.
Is this what the question I'm talking
Right. So it's called.
Yes.
Yeah.
So Austin, have a seat. So what we're gonna do is this is a obviously this is a power series of some type of function, and we gotta find out what that function. But the best thing is to show you through decimals, and if you show you through decimals, if I would have plugged in n equal to 0, then I would have get what? X to the what power?
Oh,
1 over what? 1 factorial, right? And then what's the next one? No.
Oh, x to the
3 factorial plus x to the 5th over factorial minus x to the 7 factorial. And you have to understand this because this is the one of the thing I need you to memorize. You have no homework today, but if you see this is a sine graph, and this is a sine graph, right? What I'm gonna do is I'm gonna take this, I'm gonna say f of x is equal to, first term is x. Do you see that middle region here? That they are just on top of another line. They're exactly identical if you're going from negative 0.05 to positive 0.05. The output is almost identical because they are, at that particular part, it's a straight line. If you go into here, you say, okay, well, let's add some term. I'm going to subtract the second power series, which is second iteration. And that's going to be 3 factorial. And you see that is going to be start bending the n toward looking more like sines. Is that okay? And then plus x to the 5th over 5 factorial. And obviously you see it starting bending backwards. And then minus x to the 7 and over 7 factorial. And start everything almost look at the same. I'm going to keep on adding x to the 9 over x over 9 factorial. 9 factorial. Factorial. And you see that it's getting better. Now, remember, if you do radius convergence here, it would have been where? If you do it correctly on 57, what's the radius convergence?
negative infinity to infinity.
Yeah, negative infinity to infinity. So that means you can imitate the whole function from negative infinity to infinity, depends on how many iterations you do. So right now it's actually from positive pi to pi. It's actually pretty good. But we can keep on going. We can say it's minus x to the 11 and over 11 factorial. And now it started getting even better. Plus x to the 13 over 13 factorial. And you see that almost all the way to like even more here. So we're going to see here minus x to the 15 over 15 factorial. remember radius of convergence is from negative infinity to infinity. I'm just gonna do one last term here. Plus x to the 17 over 17 factorial and factorial, and you see that all the way to the, if I keep on going at it, it's gonna be eventually keep on going until they completely match up the whole thing. But that's only if it's to infinite. That's why power series is to the infinite. And this radius it converge is from negative infinity to infinity. Some function are from negative 1 to 1. Some function from 2 to 2. 2 to negative 2. Some functions from 1 to 5. Really depends. Endpoints also included sometimes endpoints not included. You have to plug in those points to test the endpoints. Now, not only that, this is f of x, right? Imagine if I were to take a derivative of this particular function. If I take a derivative of the x, what am I going to get? 1. Or am I going to take a derivative of x cubed over 3 factorial? Over? No. If I were to take a derivative of the x,
Oh,
like
over 2 factorial.
over 2 factorial. So you'll get all the even one. So it'll be 1 minus x squared over 2 factorial plus x4 over 4 factorial minus x6 over 6 factorial. You're going to get all the same. So check this out. This is what I'm trying to show you. The f of prime of x of this is actually almost the same as cosine of x. One less iteration though. So see that cosine of x is actually match. So you can take a derivative of a power series on one side. It's going to be the derivative from the other side. So what question 57 wants you to understand is like show that f prime of x equal to g of x. Show that g prime of x equal to negative fx. Identify the function f and g. The only function that is going to be derivative of something is going to be the other function, and take a derivative of that other function, go back to negative original function. The only time it can happen if it starts with a sine. It doesn't even start with cosine. So what I'm trying to say is this. This is actually representation of sine of x. This is on today's notes. This is only, you don't have no homework. You just have to know that sine of x is represented by x over 1 factorial minus x cubed over 3 factorial plus x5 over factorial minus x to the 7 over 7 factorial. You have to memorize that because that's going to be good for your next test and also good for your AP exam.
How did they figure that out?
Using Taylor series, which as you watch that video, you should have known. At third period, you say you watch a video about Taylor series.
I did. Like, I actually did.
So you have to use the Taylor series, which is we're going to do tomorrow to figure out why is this equation using Taylor series. But we also going to learn the why the Taylor series is invented, who invented Taylor series and how. And that's going to be the part that I'm not going to be perfect at it. I know how to apply Taylor series, but to teach how the derivation of a Taylor series, it's not hard, but just not something I have done normally. But I'm going to try because I think it's much better to know where the Taylor series come from rather than just apply Taylor series. A lot of people says Taylor series is such a hard thing. Like you hear all the rumor about, oh, you Taylor series. Yeah. Actually, Taylor series is actually super easy. You just have to take a derivative like 6 times. And then you just plug in the value. And then just plug in the formula. And you got your Taylor series of sine of x. You got Taylor series of e to the x. You got Taylor series of cosine of x. Natural log of x. Huh?
The one that I was watching, it was more going over like the e to the x rather than the sine of the x.
Well, e to the x is actually, funny thing, you mentioned the e to the x. Did you do question 58?
Partially.
Okay, so here,
that's the thing.
Yep, that's the thing. All right, so this one is going to be, well, the first function is, first thing, if I plug in n equal to 0, I should get 1 because anything to the 0 power is 1, and 0 factorial is 1, and negative 1 to the 0 power is 1. Minus x squared over 2 factorial plus x to the 4 factorial minus x to the 5th over 5th factorial, x6 over 6 factorial, and plus x to the 7 or x to the 8 over 8 factorial, and dot 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 dot. Now pay attention. What happens if I take a derivative of the x? 1, right? What happens if you take a derivative of x cubed over 3 factorial? 3 dropped in the front, 3 times 2 times 1, and that's equal to x squared over 2 factorial. Does that look familiar? Every term match up. If you take a derivative of x phi over 5 factorial, the phi drop in the front, phi cancel out. That's going to be x to the 4 over 4 factorial. Same thing, x to the 7 cancel out, x to the 6 over 6 factorial. So it proves that derivative of the sine of x is equal to cosine of x in terms of power series. Power series actually work just as well. You get me so far?
Derivative of g of x, would it be like x to the 2n minus 1 to n minus 1 factorial?
You're actually on the right track. So let's go to prove if that's true or not. So you're actually on the right track. You actually start doing the question 57. So let's try this, right? So we know this is f of x. Oops, my bad. Let's take a derivative of this function. So d to the dx of f of x, summation of n equal to 0, infinity. Negative 1 to the n is not going to change, right? Because that's just a constant that's in the front. But what's derivative of this? X to 2n plus 1.
2n plus 1 times x to 2n? Like
X to the 2n, good. Over 2n plus 1, right?
Yeah.
Times 2n plus 1 times 2n factorial. Does that make sense?
Yeah.
So that's equal to summation n equal to 0, infinity negative 1 to the n, x to the 2n over 2n factorial, which is just like equal to g of x. If you take a derivative of f of x, equal to g of x. Now I'm going to have to do one more time. What happens if you take a derivative of the g of x? Now this one's a little bit more complicated. So g of x, that means if I take a derivative of summation of n equal to 0, infinity negative 1 to the n, x to the 2n over 2n factorial. What happens if you take a derivative of that? X to the what?
2n minus 1.
2n minus 1. 2n minus 1. And 2n cancel out, right? Negative 1 to the n, and this is 2n, and this is 2n parentheses times 2n minus 1 factorial. Summation of n equal to, now pay attention. Is n equal to what?
Negative 1.
No, 1. Because this term, after you take a derivative of 1, it's go away, right? So it'll be n equal to 1 rather than n equal to 2, n equal to 0. Are you following me so far?
Following me one? And n equals 1? Because if you took the derivative of the first term on that one, n equals 0, then it equals 0.
Yeah, the first term it was x. If you take a derivative, it's going to be 1. After you take another derivative, that 1's going to go away.
Okay.
So it becomes star n equal to 1.
Okay.
Is that okay?
I like you start the next term.
Yeah. Because the first term gone away, so you start the next term.
Yep.
Now let's apply shifting.
Yep.
Shifting backwards. Let's rewrite this as a summation n equal to 0. How do I write it? Go back to n equal to 0 of this. So infinity, so everywhere you have an n, because you shift it back 1, so you are gonna have -1 to the n plus 1. You're gonna replace the n with the n plus 1. Does that make sense? And x to the, well, n is gonna replace n plus 1, so it'll be 2 times n plus 1 minus 1. So it'll be 2n plus 2 minus 1. So it'll be 2n plus 1. Does that make sense? 2n plus 1 over 2n plus 1 factorial. Does that look familiar?
That's the one we just had.
That's the almost the one we just have. Almost. See, this part here is to -1 to the plus 1. So what's the -1 to the plus 1? Can I take that out? Does that make sense?
Oh, that's what you mean. Wait, why?
Because -1 to n plus 1.
Because we want to make it original look like this function. This one is f of x. Now, if it's -1 to the plus 1, so can I take that plus 1 all the way out to the front of the summation? Now, we know this is what? F of x, right? Now, here's the thing. Which function, if you take a derivative, is going to be the other function, and you take a derivative of the other function, becomes negative of that original function.
Is that what you're trying to say? Like cosine x, derivative of cosine x is negative sine x.
Yes, but you start with the sine of x though. F of x is represented by sine of x. The g of x is represented by cosine of x. G prime of x is actually negative sine of x, and that's why this is a negative of f of x. So that's why part C of the question is actually interesting. Part C is asking you to predict what this function will be. Like if you take a derivative, you can get one other function. And if you take a derivative, this other function is going to get back to negative original function. The only function that does that is a cyclic, that go in cycles. The only function goes in cycles that in terms of taking derivative, it's only sine function. Not only in cycle, but it's negative a version of the original function if you take a second derivative. So it's actually a very interesting question. It established a proof of derivative of sine of x equal to cosine of x, and then also derivative of cosine of x equal to negative sine of x. Now, for me, today your work is make sure if you can want to make an index card or make sure you memorize this, I will be like hallelujah. Why? Because this is something that we're going to be using all the time in terms of AP exam. AP exam is going to ask you to memorize 3 different series. One, sine of x. Second one, cosine of x. The third one is actually e to the x. The fourth one is natural log of x. And the next one is the geometric series, what you can actually using power series to derive all other series. But the 3 things I want you to memorize is sine, cosine, and the e to the x. And those are things that we use often. But we can use Taylor series to derive those formula though. Yes.
One thing, so like we're doing sine of x and cosine x, right? With polynomials, right? Right there, and that's okay. Like what if there's asymptotes? Like for example, with tangent x. How can you use polynomials to represent? You understand?
Yeah, but in terms of tangent of x, let me make sure. In terms of tangent of x, there was radius of convergence. It can only qualify for certain parts. It's not able to qualify all the parts.
Yeah.
So I'm gonna go back and make sure that it's right. So I'm gonna find it for you. Yeah. So for tan of x, it's gonna be from -1 to 1. Oh, for arc tan of x. Arc tan of x is gonna be from -1 to 1. Okay. So tan of x, it might have some restriction. I don't know.
Yes, kind of. I was just thinking.
So
if you add.
So you look at this page. You can come here and take a picture of this page. This page has all the function,
You got
Right here.
all the function. It has all the interval conversions.
Yeah.
But you see that sine and cosine is from negative infinity to infinity. But the tangent is
Yeah,
actually
you can't. Okay.
probably from negative pi over 2 to pi over 2.
Yeah, you can't. That makes sense. Yeah.
So this all the power series of all the elementary functions.
Interesting.
And the funny thing is you can actually get this. You can get this. You can get this very easily. The funny thing is you can replace that 1 over 1 minus x. And you can replace that x as x minus 1. So then you become a power series of 1 over x.
Interesting.
But it has radius conversions between 0 to 2, not a whole thing. It only works between 0 to 2. It doesn't work in infinite times. And actually, you can take this positive x, change it to negative x, and that's going to give you negative x. So remember that last time we did 1 over 1 minus x.
Yeah.
It's actually 1 plus x squared plus x squared. Now you just replace everywhere the x, you're going to replace a negative x.
Yeah.
And then it becomes positive and negative, and that becomes the. Now, you can take some other one and you can take an integrate of it. It's gonna get this. If you change it, if you alter a little bit and alter a little bit on the right side, you can actually change it and integrate both sides. You're gonna get this new function, which is you can represent any type of function in term power series,
That's interesting.
and which is super cool because you can actually do e to the x arc 10 of x.
That's some weird thing.
E to the x is this, and arc 10 of x is this. And you can algebraically multiply out, you're going to get a new function. And that's going to be a polynomial of e to the x arc 10 of x.
Interesting. Yeah. Very interesting.
Yeah, it's like,
Can't even imagine.
how did people come up with this? Just like,
Without calculators.
without calculator. This is 1600, 1700?
Like no decimals. Yeah.
No decimal, no nothing. And then how do they visualize the graph? How do they come up with this
That's crazy.
extraneous stuff? And they actually, the way they want to prove, they just plug in the number. See if it's true. And they don't have no calculator. So they need an approximation to figure out what the sine of 1, what the sine of 2, what the sine of 3. They need an approximation of it.
Yeah. Right, yeah, very
Can you explain the negative part again? Like how did you get from like the g power of x to the negative?
Yeah, sure.
Did y'all get like?
What I'm confused with the loop part. Like how did you get to that part?
Okay, the shifting,
Yeah.
that n equal to 1 to n equal to 0.
For 20?
Yeah.
Because ideally, I want to convert back to n equal to 0, just like original function.
Yeah.
That means I need to replace all the n with n plus 1. So I can move this backward 1 unit. If I have n plus 1, then that's going to be the same thing. So if you think like 1 right here is 1, right? You want to plug in 0 and still equal to 1 here. So it has to replace that n with the n plus 1. So if we're shifting n equal to 0, I'm just replace that n with n plus 1 and replace this n with n plus 1, but if I distribute it, I'm going to get 2n plus 1. And then here, I'm going to do the same thing, 2n plus 1. Now, why? I got everything in terms of this format now, in terms of f of x. Now, all I got to do is take out this negative 1 to the positive 1 power, because I can say that's negative 1 times negative 1 to the n, because negative 1 to the n looks like this.
I'm confused about how you shifted it like that way. I understand everything after that, but
Okay, so think about this. This is n equal to 1. What happens if you plug in 1 here? Negative 1 to the 1 power, right?
Yeah.
Now, I'm going to, instead of start at 1, I'm going to start at 0. But if I want to start at 0, I still wish this to be end up to be 1, negative 1 to the 1 power. And the only way to do that is I do a n plus 1. I replace the n to become an n plus 1 because I shift it backwards.
oh, I see. I think I see.
And then that you can take out the negative 1 out here, and that becomes negative f of x.
You're plugging in for like the n plus 1, right?
Yeah, I shift it back.
All of it.
Yeah. all the n I replace with n plus 1, and then I can start at n equal to 0 rather than n equal to 1 because my original function started at n equal to 0.
So equal to
Yeah. What happened?
Just revolve stuff.
Just revolve. Revolve is a good catalyst in the car.
okay.
He's like an enzyme catalyst.
Wait, so what about for 58 when it's asking for the function? Like,
Yeah, you gotta figure out what a function
what
is.
the hell? How are we supposed to figure that out?
If you take a derivative, you'll find out.
The derivative of
Use the same idea here. You're gonna find out what is the f of x here.
But how the hell are we gonna find? What are we gonna?
It's actually easier than this one.
Can we like plug it into a graph, or do we have to like figure it out?
You can plug in a graph to help you, but you can actually figure out using this idea of shifting one over.
So how are you supposed to find out it's like equals to like sine of x or like cosine of x, something like that? Isn't
So for example, this one, we don't know what function is until Anthony says he looked it up, he know what a function is. But before he looks up, let's just say imagine Anthony didn't look up. Which function, if you take a derivative, is gonna be one other function that if you take a derivative, that other function is gonna be negative original function.
You just recognize the pattern. That's why
We already have to do that for like.
it goes negative, bro.
No, but this is for you to understand how this works. I have seen competition question like this before, not a question like yours, but it's to understand that they kind of, because I remember there was one time that it happened like you, like there's one student that come up to me, is like, Mr. A, let me teach you how to do the problem. It's using the idea is, we don't know what a function is, but which function derivative, two derivative later, it's gonna be negative of original function. And you have to figure out that is the sine of x. And he used that idea to figure out how to solve a competition problem. And the competition problem is something completely out of whack. And he's just like, oh yeah, that's that. I don't remember which year it is, but there was a 1 year that they say f double prime of x equal to negative f of x. And they say, figure out what is c or something like that. They give you something, information. And you had to figure out, oh, f double prime of x equal to negative f of x. The only way that can happen is going to be sine of x. No, it's going to be cosine, negative sine, negative cosine. Same.
You know what? I did not say no. I said no.
You're so lucky what?
He has like.
What's the read lit chart? Is that what you guys do? Lit chart? What? Lit chart?
Wait, so we have to derive it, right? And then set it like shift it.
Yeah. You caused me so much trouble. This is the second time. I hope this is the last time. I don't know. I'm gonna make it harder. No, it's not much harder.
You are a tank. Nathan is.
What? Give me a second. I gotta take care of him first.
Bro, I heard she's like, dude.
Wait, why do you know? You know that. Why do you know?
I felt like I had a lot of things that I couldn't have a case. So I have my laptop like different edge, it's like downstairs, right? But when I put my iPad there and I turn it around, yeah, so I'm looking at my laptop. I just got my laptop back today. Yeah, but it's kind of like a bootleg thing. So like I need to go back to get my camera sites. Like this is like a camera stuff connected. And it's like,
Why? Okay. The picture doesn't go right. Are you standing with something? Why?
you're probably brown. Here's my left hand.
So we have to set the math of 330. I'm just trying to take this off.
But I heard like the method is to like
Oh yeah, bro, when it came like this goes.
yeah.
It's even worse when they're on like this goes so bad.
But I'm not the method, bro. Don't shower like a week before competition. That's wild.
What the hell? Why people doing that? You can go, right?
So it's gonna be me,
Can you
Kelly.
can you someday bring your brother here? I wanna.
Looks good.
He got no even for you have it. Yeah, I'm not saying.
An actual pickle. Even if I
Okay, so we're gonna work on a regional test. Yeah. You play ping pong, Luke? Huh? Regional. The next one is March. So the level is harder. 2016, 2017. Calculus. You don't have homework now. You just had to memorize the.
Dude, you're
Coming back. Well, mechanics is the same exact thing as it's the same thing. Matter of fact, it's easier.
Wait a minute.
Here, the only thing you have to know about calculus is that integral is area under a graph and how the graph works. No.
Matthew, I'm gonna airdrop to you. Look at any airdrop to you. It's an individual test. I don't know. Or you can airdrop to him. Don't miss the test day. What? Oh, it's right here. I can give it to you. Give me a second though. Huh? No, do it in group so that way you can figure out harder problems.
But I thought I was getting it.
Wait, what is that actually doing?
I wish I didn't even do it.
There's one more good answer, right? Instagram Reels is yes, it is. Maybe for one
All right, so
that's like your fast. No, it's like your fast. No, like Adam and Ethan, they're not.
give me a second.
Since I don't get it, that's not the point. The point is to still live it out there.
Yeah, I know.
So you just
Armin,
Amil.
Amil.
Yes, put in the negatives. There's a 2.1 and 2.1.
You didn't do that. No.
Okay, so for you,
No, I'm fake, so.
It's not.
Watch the hand. Oh, wait, here it is. Oh, wait, no.
okay, I'm gonna airdrop to you, Jamie.
Here is a 10. No, not a 10. Not a 10.
I don't see your phone. What is it?
Yeah. Oh my god, it's a music video.
Jerry, can you go to Seminole or no? March 2nd. Uh-huh. I thought you asked for the 5th. Huh? I don't know. It doesn't go through. Huh? You got it? Okay. So break out. You can work with them. You can ask them.
Okay. I can learn that over a I thought that that's what and I wasted a good hour getting the wrong
I remember you looking it up and before I started, I was like, "38." And he was like, "No,
they're wrong. He's like, you're so good that you're really down. You're asking about I never do something new. Oh, that's what I'm going to tell you. Okay. So you I had travel burgers. Hey, okay, yeah, but that's all about today.
no, he said it because he doesn't really know.
Yeah. Ever. Order for fast in what? On the same scale? Like, 4. Who the hell is the brother? You're like, he will, like, he goes, no.
Fun.
Whoa, holy shit. I know, it's so true. Like, I can actually see, like, I think I have extra. I can see Carly's nuts. These glasses, they're so good. But they're like, fine. Let me see.
For send them.
Damn.
No, those are really sweet. I love it. Yeah, if you
I think I should.
One eye.
Like, it's kind of weird for you guys.
I wish I did the frogs.
Oh, yeah.
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 If I close my.
But, like, if you go through it, it's like, weird.
Yeah.
I can read the book.
It's one eye.
I gotta be like really still.
Dude, why don't that shit?
I actually. Chipotle tastes great.
Oh, yeah. Yeah.
My aunt called it.
Well, in fact, that's when I was like,
You know what? And just because I'm so Why does it matter?
holy shit. Yeah, close your right.
Whoa. I can't believe Kevin went through it. The second thing. The left one. Oh yeah. It must be goddamn bad. So it's insane.
You just got new prescriptions, right?
Crazy. Too much.
I can see like
You know,
It's a little bit of school. Microsoft. Really bad. I did not.
Can you read after your glasses?
yes, I can.
You see this? You see this? You see me?
Wait, take your glasses off and read the name.
You know what they're for. They got up and left. That's exactly what I did not.
Where are your eyes? Yeah, they're like very.
Alright, guys.
Eyes are lopsided.
Come on. No one they have.
Right now. Well, like, what is it now?
You must have.
Guys, I don't have like a disease, bro. Just one of my eyes versus the other.
Really. Don't worry.
Alright, guys.
That's the answer.
What? What do you need?
For the one that you did like this, where you said to make them all like maximized, wouldn't that, and if they cancel, wouldn't it just be n? And then limit of n is infinity? Like, how does it become?
You're not trying to
I
maximize.
thought you said we make a.
Yeah, but and this. Hold on a second. Take care of this first. Pre-cal homework's posted now. Sorry to this long.
Yo, Tony, come outside real quick.
Why is Kevin outside?
Because I'm the ice.
Let's just have Where did Kevin go? Where did he go? He went.
I can't see it.
Kevin.
You have to be like.
I'm negative. I'm nearsighted, so I can see things better.
He's out there.
Well, yeah, you know, circle is beautiful. It's the only, it's an eye that you actually see.
How do you get this on this?
What do you have?
I don't know.
We have to
Yeah, 2,000, and I can see out of the building.
Playing my eye.
I feel like it's
Dude, you know I know the
maybe
words
three
for all the words for my eyes.
He's not.
Trust me on this. Trust me on this.
Bishop Morgan to MIT for rowing. That's what a ton of people do.
Did they have
I know two people now have gone into rowing.
Can you bring that board up? Oh, they should have done No, that would have been creative.
You can only see out of the side.
But I don't know if you got.
I don't think Bergen's like
Oh
I
yeah.
don't know if she got offered. Like a scholarship. Why you going outside?
She did. There's no
I have a ball.
Can you open the door?
Keep on himself.
Yeah, the homework's here.
Oh,
We have the homework. Like the second you left, he posted the homework.
See you guys.
Bye bye.
Don't have the joint.
Get out of here.
Bro has to eat his
Why were you playing basketball?
When I was like in elementary school.
I got mine like second.
I'm gonna
Where's my mic?
And then for tangent, it's 1 minus e squared, right? Tangent's 1 plus. Which is 1 minus x. Now, you see, Kevin and I are really good friends.
You know what he's not doing? Getting me my Lebanon. Where's that at, Charlie? Where's it at, man?
Corbin is a ball.
Did you get this picture?
When I grow up, I'm gonna name my kid Corbin.
Yeah, that's what it is. I'm going to change my kid's last name to Lewis. In honor of Corbin. You name your kids Corbin Lewis. I swear to God.
How are y'all doing? I'm naming him Corbin and Lewis Sarah.
That's crazy. You're not Christian.
More times.
Corbin and Corbin is sorrow. It's a very I would think actively make your child's last name sorrow. I would Right? Yeah.
Kevin's kind of
Never speak again. Tony, what was that?
Reason why this is expected.
You literally laugh like that on their exit.
Oh, no, what's the double line? How do you equal?
Wait, cosine?
Oh, no. I forgot to add.
Your brother?
I was an opposite there,
That's hard.
He's the one with the C.
Oh, I didn't think that'd be hard.
Like,
Thinking positive
Wait, what was the question?
I like
That shouldn't be a hard question.
I mean, I think I like Seth. I do like Seth. I like Seth.
Ethan, come on, that's not.
No, I do.
Clearly, I should be first.
You almost said
Stop.
thanks over.
Are you implying that you're up?
What are you doing?
No, you're not implying. You're outwardly stating.
Make sure they're right. Make sure they're right.
When you go ready to
Hey,
People are here. Hey, you can always do that later. You didn't take a picture?
You
Yeah. I mean, I didn't.
Wait, all of these are for art, right? Not. Yeah, so they are for all art.
Minus two next cube. Is one.
What?
Left you.
That's the loudest I've ever heard. So this is
Yeah.
Yeah, it is. Well, no.
Oh, okay. 1/2.
And then do 1/2. Yeah, you did it right. And then you can use switch to even bring the two. I am pretty awesome. And you are switched there. No, it's because he switched there.
I'm smart. You were
Honestly, Seth told me. It was really weird. Last year knows a lot of stuff. Like, we would ask him stuff like, oh, Pokemon number 142, and he would know. It was weird. Exactly. Wait, 140? Wait, hold on. It's gonna be it's gonna either be like a legendary or like Dragonite. It's gonna be like close to the end of It's 9 before Mew. Yeah, before it's probably gonna be like electric, or not electric, electivire or something. Hold on, now I need to know. Yeah, that's why I was like, never mind. Hi, Mr. EA. Now he looks like Pokemon 142. Eric! That makes sense. Oh, wait, try to put my phone away. I need it. He looks. How do you feel about what? Listen, like, you just know I'm not part of that discussion. Hate fighting. I played like talk about Cyberpunk then. I played like talk about Cyberpunk. I played 2 Pokemon games, okay? Okay, let's talk about Cyberpunk then. Tell me about like literally everything about like okay, what about friggin'
Did you get the
whatever that game is that you talked to me for an entire period about? Anarchy Online. Anarchy Online, yeah.
Did you get the shirt too? The heart? Oh.
So then why does someone write on the board you're like,
And it was after. Come on, I asked. So. Kevin. Tangent. Tan secant squared. Maybe somebody read that before. I might be a liar.
Wait.
Mr. A's like, oh really? No way. I actually don't really lie. I think the two just ran away. Who was it here?
Yeah,
I think it was Talia.
it says 1/2.
Talia from
Oh, yeah.
No.
Watching.
Wait, what? Right?
no. What did you do? What the hell? What did you do?
Oh, that.
Yes.
Let me like whatever is
Did you leave it like? Did you leave it out? Combine those two fractions. Come on, come on out.
Yeah.
Divide by a fraction.
Oh,
Yeah, I did the same stupid thing. Stupid was. Wait,
No.
what was stupid about
What
that?
is that? That's the either parts. What about the?
You're leaving?
Oh, right, yeah.
Car broken?
Oh yeah, he was talking.
I did the same thing as you. I thought why X is
Oh, wait.
I'm not gonna work. I'm gonna test it.
Did you get a sports car?
I don't have midlife crisis. I'm not midlife. I don't need to go through.
Yeah,
Like how you struggle.
I can get one.
dog more.
It's like very popular. Nobody's buying it. The slowest, like, nobody buying it. They don't want to have the price. Nobody's buying it. So, yeah, they usually stuck in the car for like people. Even people like they can give the price, they won't even watch $100.
You think it's just X squared?
I didn't really let it sit in a lot and lot.
I don't know if that's how
They won't know. It's like 150.
Wait.
It was like that.
Yeah, you look like each one.
It's not real people.
Oh, wait,
But
yeah.
again, it's really electric.
Hold on. No. Oh,
Yeah, Mitsubishi has a lot of. It's probably based on what.
I did. It's X squared over X squared plus 1. Because you have to multiply it.
The last time I saw it,
Yeah, I can hear it.
you have to multiply everything. So then you get X squared.
I don't like switching here. I use. Or which one do you use? Stupid bitch. For my kids in my classroom.
You don't need natural level.
That's correct. What's
When you take the integral.
you doing? That's worse.
What?
You can't take the regular derivative of 1 over X squared. You don't need natural level.
Okay.
That's the
Oh, wait, no, yeah, no, sorry, it's
You want
super.
5?
Of 1 over x.
So how did I run over 10 go? That looks like basketball too.
Shut up. That is. Yeah. You need to be careful who you hang on for. Open is not a open right now.
Is it 1 over X squared plus 1? Is that
So if you take a derivative of this, 1 over 1 plus 1 over x squared. But in order to simplify this, is 1 over 1 plus 1 over x squared. So you can multiply this by x squared over x squared. And that's going to give you 1 over x squared plus 1 over x squared. And then your answer should be x squared over x squared.
So it's not ON. There's no LN. There's no LN. There's no LN. That's what I thought.
okay, but what do you mean you'll never listen to me again? You're gonna listen to Adam, who also got it wrong?
No, don't make. I would not listen to me.
Okay, it's like blind leading the blind leading the blind.
Yes, exactly, that's exactly. And then you're, ironically, you're the only one with good vision.
That's negative.
That was just me.
I know that I can make jokes about it because he stated that he doesn't care.
Rub it in though.
Y'all got a lot in, bro. I was playing basketball and y'all like a 10-minute head start over me.
This is why.
This is my. This is the opposite.
Adam, can you come up with an algebra?
Yeah, I'm the bad, like, weak spot of mine.
Cosine of
Private tutor.
Yeah.
So it comes on for that.
No, because we have to go to integration.
This two
It really was.
with this.
Starting to.
I know
All right, I'm making a mistake right here.
Wait, where's the eminent statement?
This one is should be what is it? Negative 1 over x squared.
So for you.
Oh, so it was right.
You don't need a natural log.
Yeah, but the second time, he said, "Hey, there was a ribbon idiot." And I did it. So maybe the function yelled, I never yelled. Now we can't. Now it really is the blind leading the blind leading the blind. You're right. I really can't.
So the whole function is actually the.
I should have known I was correct. I should have said, "Wait a minute." But also, why would I ever say that to Mr. Donald? I don't know why. I just find it really funny saying Mr. Donald. Or just Donald. Like, saying his full name is funny to me.
Good night, Anthony.
They say that there. Really like having this 5 minutes.
Well, I can't.
I'm doing the sense.
No way.
I'll blame Kevin.
Make sure you do check.
Oh, okay, so it's cosine x. Cosine x tangent x. For 6. No, for 6, not for.
Because for six we had minus one.
I put cosine.
What is, you just put in the A1, also here, just put for each. No.
Okay. That was probably worse. Oh, you were. Yeah. Wait, which one is
That's. This, we'll just clear the whole function.
This is our one, by the way. Once you simplify and you do
Hey, right. Hey, at least like
the whole thing.
vote for something. Why is it not like
Yes. So then,
No, sir.
Oh my god, you're so.
I am learning.
No, you
One
just
and
went.
one next. You're gonna get exact thirty.
one out of 10.
You're gonna get exact same statement. You're gonna equal to 2 equal to 2.
Everyone else ready?
That's the only way his. It's the only way his radiator's broken. Okay. It's like 8 years.
Hey, you don't
Yes.
I think Kevin has three.
Man, I'm just gonna take class.
No, I never mind.
What the heck, Mr. Yang? You're endangering all of your students. I'm telling you.
That's why we. That's why.
How was my driving?
I got 3 cans of 5.
Driving one time. I'm the girl that
Did I cut you off?
No, it's just yay.
When did that happen?
It happened like
Okay.
really early on.
Actual nicest person at the table.
As fun as
Yeah, probably.
Usually my days were with the box truck. Probably like directional. I'm not saying it's not me. So I went to my station. It's easy like then. Where would you call me then? Oh, I already told them.
Yes. You always would do that.
You'd be like, I was good. And I forgot. No, I didn't get a gap.
Do you think you could?
And I just drive off.
So you paid
No, that's not a weird thing. Think about it, what happened.
on the way back. You were
You didn't get the whole story. No, I mean, I put the gas pump.
Welcome to the room.
Oh,
And welcome to the 6.
And so the gas like slides everywhere.
This is all time.
I forgot I got. The worst thing is that I didn't even put a gas where it's like.
you just feel under there and do it well.
I forgot I didn't drive off. And I noticed after I drove for like 20 minutes, I was like, wait, what? I gotta put a gas in.
Well, Mr. Yang, you look at you barely.
And I drove back, and I saw the gas going everywhere.
Oh,
back to
Somebody had like a
Or it's better than Rodos. No, it's not as good as Rodos.
what, I'll get you take your car?
That's even dumber.
I didn't even.
I was leaving school and like I wanted to go. I was gonna go. I drove over to the stadium because I was gonna.
No, I mean, I'll say that I'm not.
Did you cry?
Because it's Friday.
On this.
And
Irby, is it better now? Or no?
I don't know if I. What do you mean? My car doesn't like self heal.
Maybe have you did the plunger work?
The plunger did not.
did all the homework. Well, no, I did all the homework, but I didn't.
My car doors.
It's not about you to kick the car. You gotta just actively.
Shut up.
We had 2 dents on the same time.
I did double the homework.
Hear me out.
Yeah, we tried that.
It's like
Splash down it.
I did that for the first time. Not for like the second quarter. Please don't tell me you actually did that.
I'm gonna have to try getting a new car.
Did you no, you just do it normal way?
You should put on a big.
Yeah, he definitely
So,
can.
This is.
Wait, what happened?
So this is entirely.
I drove.
What'd you get for eight?
Yeah, he wasn't.
That's not
driving.
even his car. I took it to the right shoulder.
That's what I got. Yay. Think we got it.
No, I thought it's changed.
Yeah, I had like a little bit of paint chips, but like his car was But yeah, Chase texted me and said, so are you gonna call your insurance? I said, no, I don't want to. I'm not going to. What did he do? He's like, okay, so we're good now. Like I literally set up like a volunteer. And I was like, I am not calling my insurance. I don't.
Yeah, the numerator is the denominator is the square root of 1 minus.
Fortunately, I think Rob got because when you do the they should pay at least like
You don't have to write art sign out by the way.
they should place that.
It would be times,
They can put
and then
Oh, so-
times 2.
I'll let him
Because you add 2x.
Just gonna pull the door with pen. Hey man, you crashed my car, so you gotta buy me this pizza
Over square root
right
of
now.
1 minus 2.
He's my car.
Okay. 4x squared or just?
And then you multiply it by 3. By 3 is whatever. So you multiply that by 2. And the
Are you serious?
is if x versus minus 2x over.
This art sign.
Wait,
Oh my goodness. So like I'll be big on
Negative pi over 6. So it'd be negative pi over 3.
Remember,
from negative 5 to 5 0. So you can't have shit.
Negative 2 pi over 3. Or no, negative
No,
pi.
it's not even negative power to 2. Power to 2.
But then you have to multiply by 2. But then you have to multiply by 2.
Oh, yeah.
Because, okay, look at, there's a 2 over here, right? You have to multiply this by 2. And negative, that's going to be negative.
Yo, your gravity is insane.
Negative pi over 3.
Cheated off you, bro.
Wait, yeah.
it's like inertia, yeah.
It's like on both.
I'd say I tried.
Wait, why do you use sine pi over 6?
I'm
Fine. And then one person going to take credit.
Now you have to shift.
I like to break down like that. How did it
Although, can you make sure Devin is right? Oh,
so where is
yeah, I'll figure it out.
It's part of it.
That's crazy.
Oh yeah, no.
Negative 6 pi over, yeah.
You need help?
No, negative, no, it should be just 2. What do you get the negative 6? Hi. Of what?
Yeah, one half.
No. Wait, do you want the original question or not?
It doesn't matter.
Wow.
Wait, but if you answer right, so it's wait, no, so the question was, two are solved. That's gonna be why.
Okay. And did you plug that into this one and then you have the
I know that's I haven't.
Oh, so you plug in this one out of here, right?
I swear to find the word he said.
No, never mind.
Dude, I'm scared.
How are you guys doing?
We both can answer 16.
Huh?
We both can answer 16 questions.
Okay, you want to look at the solutions?
Why is it playing X? Oh, okay.
This has to be two here. And then the two cancel out. Then you should get one with the screws and
You want me to scroll down?
I think it would be funny. So like Kevin, you're 18, right? So the prompt is number 2. So
No, I think he said only sine and tan is gonna test.
Yeah, which technically means we could have cotangent and cosine because they're negatives, but I don't know.
That's crazy.
I also do not have work in the
Look, what is that notation? Is that what is it called? The sum. You know how that's not a series, but it's a sum of all the terms. What's that called? How? Huh? The look kind of like a pie. Huh? Is it? No, I don't think so. You guys look it up on the phone? It's a summation. It's not summation, but it's the
x squared plus 1 is
basically each term is multiplied.
Yeah, so same thing, mine is just negative 12x times cosine inverse cosecant of 4 plus 1 times 2x over absolute value 2x times root 4x squared.
How does it feel?
That's the 2x times y of negative.
Like at the top.
Because not.
That's not finished yet.
Absolute value of 2x times square root of 4x squared.
Wait, is it absolute value of you or you from?
Absolute value.
Negative times negative.
Goes to 0.
And then it's over negative.
Or maybe you're capable of counting it, you know.
Because it's. And then n plus. And then n plus 1 is on the denominator. So right there.
Please get all the recognition.
Adam, I haven't really done this overall. I can't even like for my but I can use.
That's the point of trying to
That's what I'm trying. What? No, I think it's just the experts different icebergs. Somebody that's why they were very adamant. It's not the best way for this.
There's no one like that.
It's really cool.
What?
No, I don't. I don't know if this one.
I can't believe they only good two of your top 3 people are going to be raised from it. You imagine it's like
What's cycle?
I'm not.
He's established hand. What is this?
And
Like, right as you start.
Well,
It's kind of bizarre.
so
If you're ordering new
it's
that's how it's stopped.
Yeah, I know.
Oh, you're ordering.
No, you didn't. You called him. No. You looked at me directly in the eyes. You responded.
That's
Leslie, don't do it.
that's wild.
Leslie, just give me back the water. That's crazy.
This is wild.
I believe racially diverse.
How does people come up with this?
We all know, just
Right, so we're just a good influence for bad. I can tell that you're a little bit of
yeah. So
oh, I can. No, pull up like watch it. So why did that make you struggle? So the entire schedule, I not switch sports.
This is crazy.
Freaking okay. So you take the derivative and you go to the and then when you put your x, so you'll put like y minus y equals to x.
I did it for no reason.
Yeah. Oh, the spirit, what about like? Trying to. We're gonna keep happening. Oh, it's right back. So that we do.
I lost like 10 pounds.
Oh. Sine to the negative 1
Oh, and even then, it's 75. Yeah, that's what I saw. After that, I just want to see it. Yeah. We're about to if I don't get through, I'm going to go to the house. Yeah,
I have a student one there. He's an Indian guy. Yeah.
GU over U.
He's almost finished his
Tony, did you do 62?
same thing did with mom. I guess it works.
I don't think if you care about what you do, as long as you finish job. Amir, have you got anything? Back up. Honestly,
So I did.
I don't think we did it. Even if you got N, you're gonna feel it's a struggle to stay there.
Sine 2 over.
What mine? This is right. Smart. Oh,
And see
No, I mean,
the derivative.
Oh, no.
Okay.
Yeah, but the people there are different. Or people like you over there, it's just a normal C over there. It's that it's gonna be less study and better grade.
Okay.
It's gonna be like no study and they have better grade.
I don't know yet.
So it's our whole school is composed of people who actually out of this world. And the people that who, if you go in there that try to be very safe, slow, you are actually in a very disadvantage. You know?
That's not matter. I've never heard of it.
No, I mean, the test is so much harder. Like when you go to UF or you go to MIT, the test is gonna be it's gonna be like another level.
If I do make up for it, then my drama.
No, okay. You need to rationalize the denominator.
You got white from there.
You need to rationalize the denominator or no?
Yeah.
You do?
Yeah. So not necessarily better. And then
I'm just 15.
I mean, think about it. You as a fighter, you rather take.
okay, so okay, that's for example. I don't. My brother he went to NYU
Oh, I got a better grade than you. What are you talking about?
for 4 years at NYU. And you thought NYU is very good college, right? Now he's getting paid.
I appreciate that you're trying to get your no problem. I'll let you know if
I have no idea what it doesn't really matter. Like people think that if you go to good college, you should automatically represent something. You have to college with the right thing. It's not even. Yeah, but nobody go to NYU goes to education major. But the thing is neighboring college. Yeah, it's good, but it's not as effective as for people to get a degree over. It might not be as charitable as you think.
No.
It's like there's always like hypothetical thinking. You go to MIT, come out with a job perspective, it's way better. Yeah, it's way better, but you have to be able to come out at MIT. That's the problem. That's the problem because if you are competing with a bunch of kids, they have to weed out some kids. They have to. It's just every college you have to get rid of 20% of people before they graduate. If you belong to those 20%, it's almost not worth it. If you're the top tier, it's worth it. I mean, no knocking on people. It's just like in Asia too, in China, same thing. Like university, Beijing University, they say that there's certain top 50% of Beijing University is all the top tier students, like really top tier, and they're really smart. But the other half of people is who really study very hard, and those people that go over there end up feeling really crappy because those people don't need to study, and the other half of people like they study really hard and they can barely make it. So ideally, I don't know. I'm just being really realistic. Is going there, you have to be special. That way, super special that to come out there and be surviving there. Sometimes if you
always hear the hard work being
huh?
You always hear you're always happy in the hard work piece.
You get to a certain point.
So like
You get to a certain point.
yeah, is that what's good?
You get to a certain point. So for people like go to OSS, right? So people go to OSS. I said, so a lot of people, a lot of kids come in to talk to me and says, hey, should I stay in OSS?
Oh,
Yeah, but to be in top 10 in OSS. Like top 5 or whatever I need or Russell, they all take you to Valencia or UCLA. So even though OSS but almost every got out of OSS they end up having better like Yale,
I've never been beaten Tony a day.
OSS. She would have said OSS. She would never have a shot. Yeah, she would never have a shot to go to Yale. She would never have a shot at Yale. But she come out of OSS, she would have 10 in OSS. She was maybe like 9 or 10. And she got out of the OSS. She would go to school in Columbia. And then also think everything's way easier. And he should feel overconfident. She feel like she doesn't need to come to school. She didn't come to school the same year. She didn't show up to school. She still had straight A's. She still had straight A's. Okay, she still had straight A's, and she got into Yale. Now, if she would have been in OSS, she would not have gotten to Yale for sure because she's compete with those people score 120 on competition. She's competed with 3 other kids that didn't count her. She had no chance to be on the top tier. So sometimes you go into a lower level school and to be the first one they help you confidence.
Whoa.
Because confidence really matter. When you go to the so when you go to compete OSS, those are like me, for example, if she stay in OSS, she have no shot. Because all those kids are way better than us. And she knows that. And we've talked to her about it. Way better than what she can ever dream of becoming. But now she's coming here, she's one of the top tier students, and now she has a shot to go to like a very good college if she wants to. So a potential like confidence level also means under the playing field is your incompetence in the lower ranking school, but you have high competence, you also excel even better. You also have another bonus point on top of that. So Joanne did that, and Joanne got to Yale. Whether that's smart, not smart, I don't know. We don't know. But I know from what I can see, Joanne was pretty smart. I've never had her before, but Joanne is not. She was over there. But she stayed in the West End. She had no chance. So the same situation applies to college as well. It doesn't mean you go to good college. It's gonna be. They still want a top tier students, even from MIT. They don't want to admit for low level. Of a job here. Now, it's such a situation. I really think about such a situation. It doesn't matter what school you go to. You get a degree, like you say, you go to Howard. You go to Howard or Harvard. You come out as doctor degree. You're gonna be Doctor. Higley. Right? Higley. Dr. Higley. Regardless if you go to St. Thomas or you go to Howard or go to Harvard. Head of Arnold Palmer. Head of Arnold Palmer is not from Harvard. The head of Arnold Palmer is the best hospital here. It's very small. It's no different. It's no different. They hire. There's a job required to cover stuff. I think a lot of people really think about it. How do you do it? Now, if you go there, you hear not gonna feel bad about competing, then you should be there. If you not worry about you say I go there and they're gonna kick everybody's ass. You should go. That's the mentality I think people should have. Now, should Amil ever do it?
Why is it just?
I think Amil is very hardworking, but I think ability-wise to catch up with girls. They are different level. No offense. And I talked to him about it. Sometimes I think that people think like I'm pessimistic. But it's like the people over there, it's usually like some few kids that will get go to classes like so you're competing with those kids. So you know
From here.
that you can compete for that you should compete against them. What are you talking about? That's why I put like that's why I put Lucas. That's why I put with those kids. How to go. Maybe my thing is I go for a day before you're right. This is what I'm observing. I see those two people competing, right? And I see it's not about that. If I figure it like this video, you will jump into the problem. You'll jump into the cycle of the problem. Smart enough, not smart enough. You have that courage to overcome whatever is obstacle on you. And it's not about ability, it's about that courage to jump in to ability. Now I can push you. I want to push you there, but it doesn't feel like you're reluctant. If you like reluctant is up here, then I will say, I don't think you can let me go to MIT just because the kids that there is they able to jump in and they able to be. Like Emma Bradford, probably can jump in. I can try my best. Look at this when we're not able to. And with Hopkins, those students go still is not going to be high level students. It's going to be at a mid.
So I think 15 negative.
So those are things that I want to. If you really think you want to compete, you gotta learn to jump in and say, I can do better. Just because
For 16 or 16.
For 16?
16. Not only
6-0.
math competitions, science Olympiad, on anything, on robotic or anything. You can make that level competed. Because I already see you avoiding it. If I see you avoiding it, when you go over there, you're gonna feel like you're already off. Because everybody's gonna be like, yeah. So I have another sentence. I said, how smart are kids? And I'm not.
I think it's 15 minutes later than already now. Someone started to finish.
She's like, sing that.
When I mix the two things up.
Sometimes I
No.
You're playing basketball?
And she told me that. She's like,
Support bench.
but I,
Not only like,
the only
I mix up 60 and 61.
like she said, she'll be at a 15.
Ways of reading this thing.
I think she'll be at a 15. So she can do, like, one thing that I will tell you that she can able to do a whole team problem by herself. She doesn't require other people to help. She can do it. And the one thing I will tell you about Ananda is this. So she, not only that perspective that she thinks that she can compete with anybody. The idea of competitiveness. So she went to theater and she just flat out auditioned. She never sang in her life before. She auditioned, she got 3 parts. It's not right. She go up to teach. She go up to teach a calculus section for me when I was absent. I thought it would be essential. I just need Ananda to get up there to teach it. And I give Ananda a textbook and they go up there and teach it. And she go up there and she teaches. Nobody ever taught her. Nobody ever told her how to do factor out of motion. She's just like, oh, okay, yeah, that's. And she go up there and she teach it and she makes her equity. Understands? So that competitive sense, really, you gotta grow when you go over there. Is to be able to compete with anybody. The mindset, not about backing down. I feel like you have still ways to go. The way to go is those kids who's had ultra talent. Not about ultra talent. It's not really, sometimes it's not about ultra talent. Ultra confidence can be take over the talent as well. So immediately when you enter, essentially ultra confidence. Also cockiness. So I would say the closest person to Bradford was Emilio Rivas when he was never. And he was just, he never does homework. He would go into the board, people ask him, and she would get on the board and she would write out. This is the first time she worked on the problem. I can't even do that. If I have to see the problem I cannot do, I will be hesitant. I have to practice so many times in order to show it in front of you. So for you guys that you guys don't understand, I can tell you, I watch lectures after lectures after lectures. Feel comfortable to present in front of you. I don't have that nerve. I don't have that nerve of Ananda that personality. They have nerve to go there and present that they They just know that they can do it. Those are the different types of people perfectly. If I want to see you, I want to see you grow up.
Kevin.
I want to see you enjoy. That type of
This doesn't.
last long. It's not about talent. You think it's about talent. It's about that's the whackness of
You wrote the problem.
anything you can do.
Oh, that's 61. Okay, I thought.
So, and that's the people who can survive everything. That's the X factor you guys out.
My brain is not.
Oh, that's
Wait, no.
And the best, they all have that. The swagness of, hey, anything you do, I can do just as good. And they can take it and just not why. That's well.
I got.
It happened with that poker player. It happened with that basketball player. It happened to that.
You're talking about the person that reminds me of Ben.
or no.
Yeah, he's good. He's good. Yeah, his name is Scotty Wayne. Scotty Wayne is so cocky that he worked at a waitress and he got fed up with that job. And he just cut the boss off the last day and he had $200. He got $200 with the casino. He come back with $200,000. Anybody ever met with him, insulted him, or put him down, anything? Come here, he said, $1,000, you want it? Make me. He was so fast. He was like, hey, I'll give you $2,000, all you gotta do is pay.
So.
And back then, $2,000 was a lot of money. We're not talking about a little bit of money. And then he come back, he ordered every single dish on the menu. Is a service to those people ever met with him. Huh? No, that was those
That's like almost arrogant.
yeah, he's arrogant, but he's cocky, but sometimes you just need that thing to survive your life.
Kind of a false bravado kind of thing.
Like I'll go here and like 16. I'm not gonna do this good. And I go out here and make hands and I roast it. That's not this
Confidence is not only about talent. People just have the confidence they can catch on any level in life. They can confidence catch on. You do it right here. I know. I recognize you. I recognize you. And they go into there and they say, you know what? I'm gonna bring like the A game. A game. And sometimes they solve that comment. They say, whoa, this guy. I love when they actually lower their skill and go up skill. I see it, and I want to be more coaching. I see that happen a lot of times. I go in, I just say, you know what, I want to just go to treating those people are way 1,000% better. They can close their eyes, they do it. But I'll I just have to know anything you can do, I can do better. I can do better than I'm not. If you have any afraid, any suspicion, I think you'll definitely need to work on confidence. Have confidence in you yet. It doesn't mean you cannot grow, but you gotta grow. You gotta say, hey, challenge your subjects. And then to me, this job. And I'm gonna do a good job. Those are the things that if you want to go there. And if you think that you can do that in the next 6 months, you can do it. And that's for you everywhere. So those are the things that I honestly think like people need to have. in order to compete at that level. Otherwise, you go there, it's gonna feel like you might as well like in OSS situation, you rather go to UF, be the top tier student in UF.
No,
You have better result than MIT lower ranking. If I take it top bottom 20% out MIT, I'll run. The real world is gonna run that way, unfortunately. I'm definitely able to do that confidence thing. I definitely don't have the talent. If you send me to MIT, I definitely have the confidence to compete, but I definitely will be outlasted. And I'm not as much as talented as you are. You're way better student. I can never show. You are. You don't know that. You don't know you're way better student than I can ever show. But that is the confidence. You know. I think I heard Callie say, I'm here just need to see more confidence. And I think you know that too. So you know that when Ananda told me, I said, you know, the truth is, Ananda, it doesn't matter where you go. Because she's on the verge of getting rejected from all rejected from Harvard, Dartmouth, NYU. Huh?
MIT.
And that's a disaster. But she already ran out of choice because she had to, if she go to UCF, it's more expensive than going to NYU. And she's saying like, I feel like anything. I said, look, Nanda, it doesn't matter where you go. It's never about the school you go to. It's always about what kind of things you bring on the table. I think people kind of like, I'm trying to say is that false perception of going with sports and define your success. That doesn't, it's not always pan out to be. And look at Nathan's graduate at NYU. Supposedly that NYU is the best school, business school. But he went there, played 4 years of video games, and he come here, he come back, get a job at Target, work as a cashier. And it's not better. It's not better at any situation. Now, if you go to UF, you can do superior. And this conversation, me and Raghav, same thing, conversation, that I can go to NYU. And there's no way I don't want to go to NYU. I say yes, NYU, you're guaranteed to get a good job. Yes, it's true. But what's the cost to get NYU? The cost is going to cost your family a fortune to stay in NYU. If it costs $400,000 to stay in NYU, I would tell your parents to buy $400,000 apartment. Because exactly, buy a house for you. You don't have to work for the house anymore. You'll be better off. Your parents gonna have to pay for MIT, right? Yeah. Huh?
It depends how much they cover, but.
Yeah, so look at a girl went to Duke and become a porn star. It's from an Indian family too. Look it up. It's on CNN. Okay, it's okay.
And it's not where I was expecting.
Bye.
Thank you.
Use computers.
You know how